From Washington, D.C. and around the world, this is Government Matters with Francis Rose, sponsored by Chiniga Applied Solutions.
The National Oceanic and Atmospheric Administration is combining its assets in information technology and space to learn more about how climate affects lots of things the government does. The agency uses those assets to predict trends. Deke Arndt is chief of the Climatic Science and Services Division at NOAA's National Centers for Environmental Information. Deke, welcome. Thanks for coming on the program. What are all of the assets that you have at your disposal to understand what is happening now in climate, to reference it against what you know in the past, and to prepare for what's coming in the future?
Thanks a bunch. So the number one asset we have are the data and the observations collected over decades and centuries so that we have a baseline to compare to. So a big part of the infrastructure of what we do is arranging that data. All of the weather and climate observations that have come in from around the world over the past decades and centuries, and we take today's observations and lay those on top of that. And as you're getting at, that's a very IT dependent, very IT heavy. You need a lot of infrastructure and computing capacity to be able to crank through the world's history and generate reports that people need to do good commerce in the US and around the world.
How is that collection different now than it was, say, 5 years ago or 10 years ago? And do you have is it possible to anticipate how you expect that data collection to be different moving forward?
So we're entering an era with a lot of satellite-based observations, and this is something that started in the late 20th century and continues today. So the volumes of data that are generated by many space-based platforms is increasingly large, and that's one of the big kind of technological challenges that those of us in the climate sciences space is. We are generating a heck of a lot of data now through computer models, through satellites, and then through more traditional observing systems. And getting those all into one place and running through those in a rigorous way remains a challenge.
Is the data that you're collecting coming in greater volumes because you're able to collect more stuff, like maybe satellite-based stuff that you weren't able to collect before you had access to a constellation of satellites? Or is it just because there are more things that you're measuring?
So it's largely driven by increased precision, resolution in the observing systems. So radar before satellites, and now satellites are capable of seeing the world at much smaller pixelation. And each one of those pixels of the things that we observe is a number, effectively. And so there are many more. The mesh that the satellites see the world through is much finer, and that means much larger data volumes. So most of the increase in the volume that we see are new systems coming online, and those systems having a very high resolution capability to observe the Earth, which generates a lot of numbers.
How does that help you and your colleagues do your jobs better? What are you able to obtain through the higher resolution? What are you able to know that you weren't able to know or know as well before?
So things like precipitation, those largely have a hard edge. So seeing the boundary where a lot of rain fell, and maybe on the other side of that boundary there are still drought conditions, being able to zoom in better on those conditions to provide what we call spatial resolution. In general, most folks want more local data, and this higher resolution capacity helps see things with a more local flavor. The broad brush, big picture climate system analysis is still very important, the story of our planet, but we're also increasingly asked to help inform the story of our lives, and our lives are local, and getting that information on the ground where we are is an important part of NOAA's mission.
Deke, I apologize if this is a rookie question, but do you have more satellites to bring you data, or are the ones that you have more capable? What's the infrastructure look like for NOAA in space?
So satellites, there are several families of satellites. There are large satellites that sit over a spot. We call them geostationary satellites, and they take a look at roughly half the planet from a long ways up. And then there are many satellites that orbit at a lower altitude, and they take more detailed pictures of the planet. The combination of those kind of helps us see through the depth of the atmosphere, the oceans, and even out towards space weather that's occurring on the Earth. The constellation of satellites is growing, and that's not just a NOAA thing. That is both the public and private sector around the world are putting more observing platforms, putting more satellites and instruments into space, and that is generating more data.
Does the fact that there's more stuff up there make NOAA's job easier, harder, or is it neutral?
That probably depends on who you would ask within NOAA. Folks who are making forecasts and analyses, we always think, hey, more data is better. Managing those systems, keeping track of the data, putting it away for safekeeping, more volume is obviously a larger challenge. It's more work. So I think in the big picture, a well-observed planet is healthier for all of us, and so we're all willing to do what it takes to get more data into the hands of people who need to make the decisions based on that data.
Deke, we have about a minute left. There was a period of time where the data collection in all types, not just in climate prediction, was exponential, and it seems to have kind of leveled off a little bit. Maybe it's not exploding to the degree that it was exploding, say, 5 years ago. Are you seeing that in your area of expertise, or does the exponential growth of data continue apace in your view?
So I'm a climate scientist within a data center, and that exponential pace is definitely still going. With these remotely sensed systems, while the numbers of instruments may not be increasing exponentially anymore, the data that they're spitting out, because they're capable of taking such a fine scale picture, that is still going. So we are still dealing with and seeing exponential growth, especially in the remotely sensed radar, satellite information, and importantly, the computer model output that helps us understand and describe what's going on in the Earth. So all of those together, we are still seeing quite a bit of growth in the volume of data.
Deke Arndt of NOAA, I appreciate you being on today. Thanks very much for your time.
Thanks for having me.